Hello, hello, hello. Hey guys, welcome to my live. Okay, I'm live for 25 seconds now, so let's start with the lead code problems. So now I have to choose a lead code problem to solve. Yay, lead code problem to solve. Okay, there's a company coding where I've divided this is a GitHub link, GitHub repo where you can find the questions, lead code questions asked from various companies. So yeah, this is what I'm going to solve. I'm going to choose some random question. If someone's there, you can, give me some suggestions to solve the problems. Let's see. Today's the first day, so let me go for an easy one. But later I'll go live and it's going to be for long questions. And yeah, I'm gonna do a live stream for Hack the Box or Hack with Me, something like that, something related to cybersecurity. The linked list cycle, kind of like this linked list. Okay. See if I'm able to solve the questions, I'll solve it. If I'm not, I'll just watch a video on how to solve the thing. 141 linked list style. And also I'm gonna show my thinking process out here. Wait. Um, I'm gonna share the entire window so that you can watch the thing. Entire screen share. So if I open a notepad, let you see the notepad here, you can see the notepad. Uh, Hello world, this is my first live stream. Yeah, created a document on live screen. No one watching, so I'm speaking to myself. Okay. So let's focus on the question. Given head, the head of a linked list determines if the linked list has a cycle in it. There's a cycle in linked list. Okay, if there's some node in the list that can be reached again by continuously following the next pointer internally. Okay, next pointer internally, POS is used to denote the index of the node that okay, wait, that's tails next pointer is connected to. Note that pause is not passed as a parameter. Return true if there's a cycle in the linked list, otherwise return false. Yo, I can't understand anything that's given here, bro. They'll give it in such a complicated words. So the best way is to, look at the yeah, we're back. We are back. Yeah, so I want to check if I'm live or not. Live. There's a YouTube channel that goes live which shows Rick and Morty continuously. You search for Tech Venture and another account where I'm not able to look at my channel, bro. I have to put that underscore. Where's the diamond is scared? You heard my channel! This is crazy, bro. Tech Venture. What's my channel name? Yeah, Tech Venture. Deventuri. Deventuri. Oh, where's my channel? There's some tech adventure, tech adventures, something else. But where's my channel, bro? Where is my channel? Chat. Where's my channel? Chat. Oh, finally, 9 subscribers. Where are my 9 subscribers? My army. Army. Okay. Okay. Hello. Okay, I can see it. There's like one watching. I'm watching my own thing. But there's nothing here. I would, I think you can just watch the live, but you can't comment on anything. Yeah, okay. Confirm that I'm live. Hello, my 9 subscribers. Okay, so yeah, here's the thing 320 minus 4. So this is the head of the linked list. So it works like this 320 minus 4. Minus 4 is connected to 2. Okay, so the second one head is equals to 1 comma 2. Position is equals to 0. Position is equals to 1. So maybe there's a cycle in the linked list where the tail connects to the first node, 0 index. So I think so as it passes through right, and it will then connect to 2. So this is in the first index. For those of you who don't know, ghosts, listen to this. So in computer science, the thing starts from 0. So this is the 0th index. So 0, 1, 2, 3. It's not a number inside the loop. It's not the number inside the variable. It's the index. So that's how it works. So I feel this is position 1. So minus 4 is connected to position 1. Input head is equals to 1 comma to position 0. 0, 1. So it's connected to position 0. Input head 1, position minus 1. Okay, output false. Explanation, there's no cycle in the linked list. So these are the constraints. Always say the constraints before solving a problem. The number of nodes in the linked list, the range 0 to 8. Why isn't there a chat option? I get distracted. Okay, back to the question. Okay, the number of nodes in the linked list is in the range 0 to 10 power 4. Minus 10 power 5 is less than equal to node dot val. Okay, whatever. Position is minus 1, valid index in the index list. Okay, so how would I solve it? See, and one more thing is to look at the topics. Okay, hash table. Okay, hash table. They want the time complexity, the time taken to solve this should be 0 millisecond. So that's why they used hash table. Linked list, 2 pointers. Okay, 2 pointers. Okay. So let me explain what 2 pointers right now. So yeah, see, this is the thing, right? This is the linked list. So what 2 pointer does is, uh, so this is pointer A and pointer B. Both will be initially they'll be in the same place. Then pointer B keeps on moving to the front. If a condition checks out, pointer A will start moving to the front. 1 second, I'll remove this graph. So it works something like this. And hashing is when you take the variable number, suppose it's 3. I'll take the ASCII, American Standard CII something, ASCII value of it, and then you divide it by the number of, how do I say this? Number of the position, say for example, there's 5 boxes here, right? So in this you add the ASCII value of 3, right? And then you divide that ASCII value, you add all of this. So the other numbers, right? 3, 2, 0, minus 4. You keep on adding it here. You find the sum of all of this. Let's take it as a number x, and I divide this by the number of blocks here. So divided by 5. And then you assign it accordingly. So, so whatever answer the sum is, so the sum answer is y. So at okay, I'm getting confused here. What happens? Yeah, for that y position, I assign 3. So anytime I want to get 3, I divide the thing. Wait, it's not divide here, it's modulus. Modulus is the remainder. So yeah. And then later what happens is here I put the linked list. So there's some other thing connected, some other thing connected. So this is how it works. And I have one doubt. Um, in Python, what is the thing called? Mm, La 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 la. Hash, yeah. Hashing example. So this is how I code. Thing is, I create an idea. I write down how I solve the code here on a notepad. Normally, I use a normal book for this, but here to show it to you guys, I use a notepad. And then anytime I want to look at the syntax or something, I use this hash. You call that hash man. What's a hash table? I don't know what hash is. It's a hash table. ¿Dónde está ese hash table? Oh yeah, this is all. Always use Google there. Always use Google. Because in Google, right, I can go through multiple websites and then it'll choose the answer. It's not trained in normal way. Because so according to this, what I can do is I can solve this using brute force. This is how the brute force method works. I don't know how to exactly use hash. I'm not that familiar with hash. So here's the thing. So what I'll do is I'll create a pointer, for loop for linked list element. So after doing that, then each number it will iterate through. So 3, 2, 0, minus 4. After that, it will go back to 2, right? And then I'll calculate the index value. So so each time it goes, it has to add it to this list. The st is equals to so and so, and I take it um, for this thing. So if the number not in list, and then list dot append in. So what happens here is Okay, but and I'll put an else condition. Else return. What do you call that? Index. Yeah. S no. LL no. List dot index. The index number n. Right. So this is the logic. What happens is it iterates through each this thing. So 320 minus 4. 1 second. Pardon me for the interruption. Oh, there are actually two people like crazy. Okay. Yeah, 17 minutes and I haven't solved a single thing. So that's what I would do. What the fuck? So that's the brute force approach. Alright, so let's do the same thing for this example. See, what one more thing I learned is go through each example and check if your code works for that. One into one, it adds to the linked list. Right. If L not okay, so obviously it's not, it's the first index, and then it'll append. So list will contain one, and then two. So n is equals to two. N not in list, obviously it's not. And then list dot append. Okay. And then it keeps on going because n is equals to n forward something. Alright, so it goes to the next one. But then here it clicks on the else condition. It is already in linked list. It's already in the list. It'll go to the else condition and it'll return the index n. So that's what is happening. But this is the brute force approach. Come on, similar questions, discussion. In equals to n. Yeah, before I do anything, I need to go through one thing. Mm. Yeah, I'm going to the file where I have solved a few linked list thing just to see how I solve the thing. I mean, not the same question. It's not a normal question. It's just practicing what linked list is. And there's no shame in going through your old code. You're the one who wrote that. Just because you don't remember it, it doesn't mean you can't solve other questions. Okay, where is it? Where is it? Where is it? Let's stop. Python and three months of a dish stuff, PFS. But I swear I had a linked list thing. Number three. What the hell? Mm, this is written example. Okay, 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 okay. The thing is, I'm gonna traverse through the linked list, right? The linked list. I need a where I traverse through it. Okay, forward and print elements. Temp is equals to temp next. I don't know what's happening. I don't know if because I'm speaking a lot or I'm not sure why, but I'm not able to think properly. So let's keep temp is equals to uh, head. Alright. So temp is equals to temp dot index. So this is how you traverse through a linked list. So temp is equals to head. So temp is here. Alright. So and it will go through each iteration and it will keep on adding it to the list. Okay. Temp is equals to head. Um, how do I find the length of it though? Okay. Wait. I'm not able to think. What's happened to me? What has happened to me? I think I've solved a lot of various questions, so that's why this is happening. You know what? I give up. I give up. All right. I'm gonna watch a lead code thing. 141 linkless cycle. Even link this cycle. Shout out to neat code. He's one of the best. Guys, if anyone is watching right now, everyone's watching. Fuck it. We just want to see it. If anyone's watching right now, go subscribe to Neat Code. He's the best. Subscribe and like his content. I'm going to comment something later. I thought this was an easy problem. Linkless cycle easy. Yeah, I'm good though. I have solved a medium problem on my own without any help, but it was mostly in arrays. So linked list, I don't know what happened to me. What the hell? You hate yourself for making this dumbass AI ad. I don't understand why do they have to make AI ads? They can pay a guy to make an ad. They can shoot the ad, but no, they want to save cash by giving the work to AI. I'm not against AI. Think I am for AI. I like AI. I'm dependent on it. But come on, man. If you have the cash, pay an actual person. That's more worth it. Okay, I'll stop my ranting. Let me come back to the video. Hello? Hello. Check, check, check. Okay, so you guys can't hear this, huh? Okay. This, this can produce a lot fuzzy echo. Let viewers share your audio, share your music, and window that's what I've done. In the screen audio, share audio tab. You share system audio, share tab audio, entire screen. Oh, okay, sure. Wait, let me think. Let's check.
Right? So clearly, in our simulation,
Yes, it's working.
eventually the fast pointer is going to reach and surpass the slow pointer. But why is it true that
GG.
they are going to meet each other at the exact same spot? Well, let's just give this distance an arbitrary value. We know that the fast pointer will catch up to the slow pointer, and this is the distance that it's going to have to travel in order to do so. This is our gap that we have to close. So let's say the length of this gap is 10. If we move the slow pointer by 1, we're taking the gap and increasing it by 1, right? If the slow pointer gets shifted by 1, we increased the gap. But then the fast pointer is not going to quit. It's going to move by 2 as well. So when we move the fast pointer, we're taking the gap and closing it by 2. So we're saying plus 1 minus 2, right? Do you see how this evaluates to 10 minus 1, which is going to be 9. So on a single iteration of the loop, the distance between the pointers is being closed by 1. So then how many iterations is it going to take for the fast pointer to reach the slow pointer? Well, of course, whatever this length happens to be, right? Whatever that closing distance happens to be, whatever that gap happens to be. How big could this gap possibly be? It could only be the entire length of the list. So, let's say the fast pointer is over here where this distance is 1. So then the remaining distance is going to be the entire length of the list. Let's call that n minus 1. So then how many iterations is it going to take to get this to equal to 0? Of course, roughly n. So that's why the overall time complexity is n, where the length is the distance, where n is the length of the cycle, which could be the entire linked list, right? So that's why it's always going to work, and it's going to run in linear time. And maybe you didn't even care about why exactly it works, but that's okay, because once you know the fast and slow pointer technique, the code is usually pretty easy to write. Let's get into that now. So, like
Finally.
I said, we're going to start our slow and fast pointer at the same position.
Okay,
And the next time that they meet each other is how we know we've detected a
okay.
loop. So, obviously, they're at the same position now. So, we
Give me
don't
some
want to
head.
say that there already exists a loop because we don't know that for
Wild.
sure. And we're going to be shifting our fast and slow pointers while fast
First.
and fast.next is not null, because we need to make sure that fast.next is not null, because remember, we're shifting fast by 2 on each iteration. And of course, fast is going to reach the end of the linked list before slow does. So if it does that, then outside of the loop, we can return false, meaning that there does not exist a cycle. But on the inside, we're going to check if there is a cycle. So we're going to take our slow pointer, shift it by 1, slow dot next. Take our fast pointer, shift it by 2, fast dot next
Dot
dot
next.
next again. And now
Beautiful code.
if they meet each other, we can
If
say if
slow is
slow
equals
ever
to
reaches
equals to fast.
fast, then we can return
Okay,
true, there does exist a cycle. And you could pretty much write this loop as a do while loop in a lot of other languages, but I don't think Python supports that. So the solution is really a
okay, so this is the solution I'm gonna play this. Oh, I love this guy, bro. He gives such elegant code. So I'm gonna make it. Anyone watching this, any human being watching this must like it. Alright, or you're gonna be sent to hell for not liking this guy. Neat code. Such a nice name. Yeah. Sports elegant. Cool. Okay, I've written this. I'm going to click on call it only if this code works. Alright, so temp is equals to head. I'm not going to use the same variable. I'm not a copycat. Temp, tempo. Okay, car, 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 head. What did I loop again? While. We used a while loop. While, what was it? Temp and temp next. Was it this? First and faster next. Okay. Yeah, you have to write temp. Temp is a slow one because it's a tempo. While car and car next. Car is the fast one. Write it here. car is equals to fast because cars are fast. And then is equals to low because life is low and temporary. Yeah, no, I don't know the spelling, so it's your problem. While car and card are next. Yeah, so car exists and card are next exists. So I put an if then is equals to car. Return if return oops. We wanted to iterate through the thing, so let's take temp. Temp is equals to temp next. And car is equals to car dot next. Dot next. Yeah, I think this is the whole code. No, not this. So, bro, this is such elegant code. I'm just, yeah, we've done this. Okay. Now you guys know me. Let's see if I can get out. Okay, I'm going to change my username first. And I'm going to remove the thing. So I could just shift that, right? I can use the same username for this. Okay, so let's just analyze the code. So 320 minus 4. It goes to 3, then goes to 2. So temp is still 3, but car is in 0. Next iteration. Temp is 2, car is 1, 2. Yeah, so see both the things are 2. In the second iteration, you get to know temp and car join each other. The same thing happens here. 1, so and temp is, no, this is O of 1 then. For example, 2, it's O of 1. What a beautiful thing. So let's just submit and see what happens. Yeah, you're not gonna see this. No, don't see my name. Oh my god, 0.74% used 54 milliseconds. Wait, so someone solved this 22 milliseconds. Let's look at the code. Wow, such a good code. Then what's the same? If not head or head dot next, return false. Or you just put the thing at the start. Slow is equals to head, fast is equals to head dot next. Okay, wait. If slow is equals to head, fast is equals to head dot next. It doesn't matter, right? Okay, beautiful. While slow is not equal to fast. If slow not fast, more fast or next, return false. Okay, so in the same condition we had, but then this is the head part. So initially there's nothing here, just returns false. Increasing the time when he's moved the thing like after the check. Well, let's see what happens to that code if we do the same. So right now it is 54 milliseconds. Let's check if it works here. Yeah, it's working. Submit. 54 milliseconds. I just note it down. 54. Yeah, it's not working. It falls 1, 2. Machine balance one. You have to check it initially. What? Oh yeah, it's a simple thing. So we've learned what? How will it reduce? Wait, just because of lines? How can time increase with the number of lines? I swear if there's any developer watching this, he'll be cool as this fool. No, it was 54 milliseconds. Yo, this is crazy. Something's wrong with leetcode. Something is definitely wrong with leetcode. Okay, I guess that's it for the live. Like, share, and subscribe. I don't think you can comment on this thing. I'm gonna go sleep. I guess like one person came to watch the live. I don't know if I'm gonna upload it on my channel or something. I'm not sure how the algorithm will take it. But yeah, adios amigos. Bye bye.